Hey, TJ here from smokescreendesign.com. I want to talk about a picture I came across, and this goes back to a talk that I gave, and I'm going to try and make this a short video. We just need to make sure that we are using uh, good numbers when we are doing our calculations to try to prove curvature or no curvature, whether something should be seen or not seen. There's this video I did. It's flat earth line of sight versus curvature versus horizon. If you come to my website and you go to the earth tab, and it's on the automated calculator for earth curvature page, and you can also see it at my YouTube channel. It's got that same name. So if you go to YouTube and just search for that, flat earth line of sight versus curvature versus horizon at Smokescreen Design, it's going to tell you all about this. Let me go ahead, and I was just playing with the numbers here. Let me cancel this out. Alright, so the picture I came across was this one. So it says this photo was taken from Winter Hill, UK. The elevation, I'm assuming that this is where the photo was taken, is approximately 1,500 feet. So that's here. And then the Isle of Man distance was 85 miles, so that's this line here between the two is 85 miles. And so the elevation of the Isle of Man is at the highest point is 2,034 feet above sea level. I'd like to know, what's at the base of this. A little more information. What's at the base of the Isle of Man? I could have looked it up, but I didn't. Is it at sea level? Is the base, where is that at? Is it below sea level? So I'd like to know more of when this picture was taken about that. So then the calculation of the curvature was the mileage times by 8 divided by 12, and that's just the formula to come out with the curvature should be 4,816 feet. So what that means is from the location where this is to this location out here, there should be a curvature at this point should be 4,816 feet. So then it says it should be out of sight below the horizon by at least 1,300 feet. So let's see if this is correct. Now, there's two things you have to take into account. Number one, you have to take in account the height of the observer. You have to take in account the height of the object you're looking at, and then take into account the distance. So let's see how these, whoever put this together, I have no idea. Let's see how they did. Alright, so the height, so this is for determining the horizon. It's also going to tell us, if we give it the distance, going to tell us how far, or the height of the objects that would be hidden. So the approximate height was 1,500 feet, and we're at 85 miles. Alright, so the height of the camera should be 1,500 feet above sea level, and then 85 miles for the distance. So the horizon from the 1,500 miles up, the horizon is going to be at 47.43 miles, and 941 feet or below is going to be hidden. So at 85 miles and at 1,500 feet up, 941 feet would be hidden by curvature. Now if we come down here, we can determine the curve, which is what this formula is based off, this 85, 85, 8, 12. So that's this formula. So let's see, curvature of the earth. Don't remember what I need to put in here. Is it 85 miles? Right, okay. So I'll put in the mileage to the other object. And the curvature should be 4,816, which is exactly what we saw in that picture. So this says that the horizon should be out of sight by at least 1,300 feet. Really, it should be, that's not correct. So anything above, so this is 2,034 feet. Anything above 941 feet is going to be visible. So let me try to, if you watch that other video I mentioned, it's going to explain it. But here's how it works. Got the curvature. If you go from ground to ground, the feet of curve is 4,816 foot drop. So that's ground to ground. But as soon as you go up, you have 1,500 feet up here, and we have 2,000 or whatever here. Now what's going to happen is your line of sight is no longer going to be cut off by this curve, but now what you're going to have is you're actually going to see over part of the curve, and part of it's going to be hidden. So that's where this second calculation has to come in to take account for the height going up of the observer and the height of the object being seen. So that's why this here is 941 feet, and then the rest of it is going to be above the curve if there is a curve. So that's why this is not correct. So this is saying that it should be this 2,034 feet should be 1,300 foot below. So they subtracted these two numbers. So they found the curve. Now you just have to determine this last part of the formula to see what you should be able to see. Now, let's see, elevation element, assuming that this here is, let's see, assuming that this here is going to be, no, that's not perfect, but assuming this here is the 2,034 feet, then let's say roughly, so we said 900 and something, which would be approximately half. So I don't know where the base of this is. If this is the base down here, oops. So if this is the base that's touching the water, then about the middle would be hidden, because that would be near that 900 and something feet, just under 1,000. So all of this would be hidden, but I don't know where the base of this is to be able to really say if that's the middle or not. I don't know if this is 2,000 here, or does it go down below the water somewhere. So that's how to correctly do your numbers, so that way we're not doing bad math and then people find out you're doing bad math and then start making fun of you and debunking you, because then you look like an idiot, and then it could turn people away from flat earth. But what will happen is that smarter people will say, okay, so you got that wrong, but let's get it right and then see what we come up with. I mean, it appears that this stuff here could be on the water. So I know this looks like this crane could be on the water. So it looks like that base could be anywhere from up in here. So just wanted to make this short, or at least shorter than my normal videos that I've been making. And so use the calculator to do good math. I've got some other ones here. You can watch that video to learn about all of these. So that's the line of sight versus curvature versus horizon. So let's make sure we do that properly. Use the good math, okay? I'll talk to you soon.